Okay, so I don't think I need to explain why optimization frequently goes together with simulation modeling. So in Anylogic, you have a built-in optimizer. We're not the optimizer vendor. Optimizer comes from American company OpTech, and it's called OptQuest. It's the same optimizer that is built into Arena software. And I think it is the same that is built in probably ProModel and maybe 10 other simulation tools. And it's the same optimizer that you find in Crystal Ball. So optimizer, in this case, when it's used, it runs as a master application that controls the simulation model. You tell the optimizer, here's my objective, minimize or maximize. Here are my constraints. Here is the model, and I can vary such and such parameter, or you can vary such and such parameters. Optimizer will run the model multiple times, search in the parameter space, and finds a good solution, or let's say suboptimal solution, whatever. Why suboptimal? Because the parameter space can be huge, and you're never unless the case is very, very simple. Nobody can guarantee that he will able to find the optimal solution in finite time. The optimizers are pretty smart pieces of software because they are programmed to work with local minimums and maximums with very complicated to work in very complicated parameter spaces. And I will demonstrate the usage of the optimizer on a small example, which is again a part of Anylogic distribution set. It's called activity-based costing. I'll first run this simulation without just a simple simulation experiment. It's a simple abstract, let's say, manufacturing facility where the parts are coming in, processed, and go out of this this manufacturing section or factory floor. We have several parameters here. Capacity of resource A, maybe workers or pieces of equipment. Capacity of resource B, the let's say the type of machine here, maybe an oven, and the type of conveyor. The type of conveyor actually affects the processing speed, but also have different costs. And we will be optimizing the processing cost per part. Up there in this horizontal bar chart, you have the total cost, total processing cost, which at the moment with this parameter settings is $180 something. And here's its breakdown. So this is the transportation time, the processing time, waiting time, and this is the resource idle time, which still this cost is allocated to according to ABC costing, activity-based costing model, to the parts. So what I can do manually while the model is running, I can let's say experiment with resource capacities. I change the number of workers here, reduce them a little bit, and you see that the idle time reduced and the total cost reduced as well. I can make the buy a faster conveyor, but it's no good really, because although it really conveys and it is faster, but it at the same time increased my cost per unit, etc. So I can change the parameters manually and see how it affects the cost, but I can also submit this problem to the optimizer. This is the optimization experiment setup. So basically this is the Anylogic interface to OptQuest. Objective is to minimize the total cost per product. Total cost per product is the function that is calculated in the model. We can look at this function. I think it should be somewhere in the main object. Functions. Yes, total cost per product. It's a simple function that returns the sum of other costs. Back to the optimization experiment. Oops, no. I wanted this guy. So, objective. Maximum number of iterations. The optimizer is allowed to do 500 iterations. And then the main thing is parameters. The optimizer is allowed to vary these 4 parameters. 2 of them are continuous. 2 of them are discrete, so it's a mixture, discrete, continuous parameter space. Minimum, maximum value, and step. In this case, step is 1. In the case of continuous parameter, step is 0. What? Yes?
Iteration count is the max number of calls to simulation?
The optimizer will stop after doing 500 of iterations, no matter what. You can increase this, you can turn this off, then the optimizer would itself decide when to stop. Sometimes optimizer says, okay, I think I've done my best, I stop here. All right. Let's run optimization. It's finished already. Without the animation, the model really is running fast. So optimizer already was able to perform, well, for some reason, 504 iterations, not 500. Maybe I rechecked this checkbox. I don't remember. This is the very illustrative graph of the iteration of the optimization progress. Our objective function is this brown line. We're minimizing the cost per product. Okay, so it goes down. Whenever optimizer finds a parameter combination that is better than previous, this line goes down. But the optimizer is searching in the space of these 4 parameters, 4-dimensional parameter space. And because the optimizer does not know anything about the shape of the objective function, it would try in different parts of the parameter space. And you can see that, okay, the optimizer found that good solution, worked around it a little bit, then it decided to jump to somewhere else to change the value of a certain parameter or maybe a couple of parameters to look in different part of parameter space. So these, let's say, unsuccessful tries, and each dot here corresponds to a single simulation run. Okay, these are attempts of the optimizer to choose different points in the 4-dimensional parameter space. Am I making sense here? Does that? Okay? So that's how the optimizer works. You can also specify constraints and requirements. For example, the queues should not overflow in our manufacturing system. And this, I think, is one of the requirements which are defined in the in here. So constraints and requirements are also part of the optimizer interface. Okay, guys, I think we're finished for the first part, and if 2 short questions I can answer at this time.
What
Could you please click on replications? So
Yes, the
If you have random variables in the model.
yeah. If your model is stochastic and you're optimizing under uncertainty, then of course you have to use replications, and this is the interface to defining the number of replications.
okay, so you can define.
Yes?
Is there any added value of using OptQuest in your software compared to using it in Arena, or is it the same performance?
Oh, it's the same software.
It's the same software.
Same software.
You have just changed your interface to make
It's the OptQuest is the same here. Well, here is Java. In Arena, I guess it's C. But well, there is one advantage because you can export models with OptQuest and just publish them on the web, run them on any machine, because it's Java, it's cross-platform, and it's the model with the optimizer can be separated from the model editor and put on other machines. So that's probably the real advantage of using Java OptQuest. Okay. Okay. I think we're done for the first part. And coffee break and.
Yes, it's time for the coffee break.
Yeah. Okay.
First row.
Mm-hmm.